Today's the last new day of material in the trig unit. It's been a long one, but we got to it. Okay, so start with some homework. The homework looked pretty good, but there were a few questions that people wanted to go over. One thing that I mentioned to a few of you, some of you had trouble on the front with this amount of daylight in Green Bay, Wisconsin. Part C, use both the equations you created to determine for what period of time, from what day to what day of the year, the amount of daylight is at least 10 hours. So a lot of you are thinking y1, y2, put the equations that you made from A and B into y1, and then you're looking for at least 10 hours. So the problem is some of you put y2 equals 10, but 10 is in terms of hours, and the amount of daylight was in terms of minutes. So for this one, you really wanted y2 to be what 10 hours is in terms of minutes. You have to put y2 equals 600. So if you had problems on that one, just watch out for the units. Over on the back with the review, these looked really good. So number 6, it's number 7 and 8 I want to go over. Some of you just forgot how to do number 7, and there's more of these on tonight's homework as well. Tangent of theta is greater than 0, and cosecant of theta is negative 7/6. Determine the value of cosine in simplest radical form. Now, whenever they ask you to evaluate a trig function, whether it's one that looks like these up here, or one that looks like this, if it says evaluate or find the value of a trig function, you need to have a picture. Okay, so where do you draw your picture? That's what these two parts tell you. Tangent is greater than 0. So this is where you use all students try cheating. And if tangent is greater than 0, what quadrants can you be in? 1 and 3. They're all positive here, and so is tangent. If cosecant's negative 7/6, remember, what does that also tell you about? The reciprocal is sine is negative 6/7. So whether cosecant's negative or sine is negative, it means essentially the same thing in terms of quadrants. If sine is negative, you can't be in A and S, so you have to be in T and C. So you should have a triangle drawn in third quadrant. Whether you use cosecant or sine, cosecant's hypotenuse over opposite, sine is opposite over hypotenuse. Either way, the opposite side has to be negative 6, and the hypotenuse has to be 7, because the hypotenuse is always positive. How do you get this side? Pythag. So you would do a squared plus negative 6 squared equals 7 squared. So a squared plus 36 equals 49. If you subtract the 36, you get a squared equals 13. Take the square root. Remember, that's plus or minus, and it has to be negative radical 13 because it's going left. Okay, so finally you can find cosine of theta by using SOHCAHTOA. Adjacent over hypotenuse. The adjacent's negative radical 13, and the hypotenuse is 7. And that's already simplest radical form. All right, and then number 8 is another graphing one. People are totally fine with this part. But let's do it because that'll help us with the graph. So amplitude, remember, it can't be negative. It's the absolute value of the number out front. So that's 2. Frequency is the b value, the number in front of the x, so that's 3. Period, that's the formula, 2 pi divided by b. This is 2 pi over 3. Midline, some of you forgot to do y equals. Remember, midline implies it can't just be a number. It's got to be an equation. That's the vertical shift. You're going up 1, so y equals 1. And phase shift. Phase shift, remember, is just the horizontal shift. And there's no, oops, what am I trying to write here? There's no plus or minus in with the parenthesis in here. So the phase shift would just be 0. Okay, now here's where it's a little tricky. Sketch a graph of this function over the interval from 0 to 2 pi. So some of you graphed one cycle. So one cycle of this function, remember, picture what sine normally looks like. Where does sine start? midline. Then it goes up, comes back to the midline, down, and back to start. So that's what sine normally looks like. Okay, if I was graphing one cycle, first thing you should always plot is the midline. So y equals 1 would be up here. You'd start on the midline, but remember it's also a negative out front, so it's getting reflected. Okay, so if I reflect this graph, instead of going up first, it's going to go down. And it's going to go the amplitude down from the midline. So the first spot would be down 2. So 1, 2 would be right here. Then I'd be back on the midline. Then I'd go 2 above the midline. 1, 2 right there. And then I would end on the midline again. And this spot over here would be 2 pi over 3 because that's the period. That's one cycle. Now graphing it between 0 and 2 pi is a little trickier. So the thing you have to remember if you're doing this is you're still going to have your midline at y equals 1. So put that in. You're definitely going to start on the midline because there's no phase shift, and I'm not going to make you graph a phase shift, so that's that. The thing you should remember is between 0 and 2 pi, that's the number that matters. There's 3 cycles between 0 and 2 pi. Remember, frequency means number of cycles specifically between 0 and 2 pi. So this is one cycle. I got to do that 3 times. So let's just draw that cycle 3 times. Let's go 2 below the midline, go on the midline, 2 above the midline, and go on the midline. There's one cycle. Then do that again. 2 below the midline, on the midline, 2 above the midline, on the midline. There's 2 cycles. Do it one more time. 2 below the midline, on the midline, 2 above the midline, on the midline. 3 cycles. That would have to be 2 pi. Okay, so if you wanted to label more stuff, you could. You don't have to. This is technically one cycle, so that'd be 2 pi over 3. Here's the end of the second cycle, so another 2 pi over 3. That'd be 4 pi over 3. And the third cycle would be 6 pi over 3, but that is 2 pi. Okay, so that's a pretty tricky graph. If you could get that one right, you will be fine on the test. But there's 3 cycles there. Okay, if we flip over to the warm-up, we got some more graphing for today. Consider the function y equals -3 cosine of 2x plus 1. Amplitude, frequency, period, phase shift, midline, and range. Do that. And then sketch a graph for one complete cycle. That's for B. And sketch a graph over the interval from 0 to 2 pi. That's for C. Okay, so why don't you try that? Pause the video. Graphing is probably the hardest part of this unit. We just went over that question on the homework. So see if you can do this one. Go for it. Okay, did you try it? Here are the answers. All right, so amplitude, frequency, period, phase shift, midline, and range. Here's part A. What's the amplitude? It's 3, right, not -3, because it's the absolute value of -3, which will be 3. Okay, what is the frequency? Frequency is 2, number in front of the x. What's the period? 2 pi over b, so 2 pi over 2, period is pi. What is the phase shift? No phase shift because, again, there's no phase shift because there's no plus or minus in here. There's no horizontal shift. Midline, just like on the homework, it's y equals 1, not just 1. And range. You can go over range on the homework, but remember what 2 things affect it. The amplitude should be -3 to 3, and the midline, +1. So the range is -2 to 4. Okay, good. B, sketch a graph for one complete cycle. We'll do B's graph right here. So one complete cycle is how I would normally tell you to graph it, regardless of if it says a cycle or over an interval. Start with one cycle. and it's cosine. So what's regular cosine? Where does it start? Below the midline, on the midline, or above the midline? Above. And it goes on the midline, below the midline, on the midline, and above the midline. So here our midline is y equals 1. So graph that first. Where's this one going to start? 3 below, because it's being reflected. Watch that negative up here. 3 below the midline. So go 1, 2, 3 below. And 1, 2, 3 below, and put a dot. And then I'm going to go every 3 again. We go on the midline. So right here, it's kind of hard to see, that's on the midline. And then 1, 2, 3, go 3 above the midline. So right there. And 1, 2, 3, go on the midline again. And then 1, 2, 3, go 3 below. 1, 2, 3. So right there. So draw your curve, and there's your graph. Now, the one thing that people seem to always forget with this is to label that endpoint. You have to say what this scale is, and that's 1 period. So this spot has to be pi. If you want to label the middle spot, that's easy to do too. It's half of that, so pi over 2, but you don't have to. But you have to at least show that this last spot is whatever the period is. Remember why I don't have to put any y values on here? Well, just because the y values are going up by 1, so that's assumed. Okay, now how could I use that to sketch over the interval from 0 to 2 pi? That's when frequency comes into play. I need to have this one cycle happen 2 times. So maybe that's what you should start with. So we're going to draw in our midline again. I'm going to use another color just to make it look a little more clear. Do this exact cycle that we did twice. So start 3 below the midline, on the midline, go 3 above the midline, go on the midline, go 3 below the midline. I think I spaced it out too far. So now I got to do that again. On the midline, 3 above the midline, and then be on the midline again, and 3 below the midline again. Yeah, so maybe not space it out that much, but you should have 2 complete cycles by the time you're done, because it's all about frequency when I'm talking about 0 to 2 pi. So this last spot over here would have to be 2 pi. This first spot would still be pi. If you wanted to label the middles, this would be pi over 2. This would be 3 pi over 2. And I realize I put this in the wrong spot. Sorry about that. Because that's the end of the cycle. That's where pi would be. Okay, but 1 cycle, big thing to remember is graph your 5 points and list the last spot as whatever the period is. I'm going between 0 and 2 pi. We got to make sure the frequency is correct. So there should be 2 complete cycles. And that's how you graph those. Okay, so hopefully that clears up some more graphing questions. Did you know Antarctica has as much ice as the Atlantic Ocean has water? That's a lot of ice. Okay. For the last day of new stuff in the trig unit, you have to use your own paper for notes. I think this is actually the last day of the year where I don't have a note sheet. So that's exciting. Okay, so we've been talking a lot about graphs of sine and cosine. You can label this unit 13, day 14. Long unit. Today we're going to talk about the graph of y equals tangent of x. Okay, so you could also do graphs of secant, cosecant, cotangent, all of those, but we're not going to do those this year. Sine, cosine are the only ones we're going to do all these crazy shifts to and stuff, where we shift it up or shift it left, all that kind of stuff. But tangent, you need to at least know what the graph looks like. So one more time, you should be sick of seeing this by now. It all goes back to the unit circle. Okay, so remember, unit circle meant that the circle had a radius of 1. So if I pick any random point, call it xy, and draw from the origin, we know that radius is 1. I'm going to call this theta. So if this is xy, I'm going over x and up y. Okay, so sine of theta would be opposite, which is y, over 1. That's why sine of quadrantals are always 1. Cosine of theta is adjacent over hypotenuse. That's why cosine of quadrantals are always x. And I say of quadrantals. Technically, it's any point on a unit circle. So it could be over here as well, but we usually just think of them as quadrantals because those are the easy ones. But the one we're focusing on today is tangent of theta, which is opposite over adjacent, y over x. And that's why we've said that's also the same as just taking whatever the sine value is, dividing by the cosine. Okay, so today we'll look at the graph of y equals tangent of x. All right, well, in order to do the graph, let's evaluate all the quadrantals. So let's say we're going to evaluate tangent of 0, tangent of pi over 2, tangent of pi, tangent of 3 pi over 2, and tangent of 2 pi. Okay, so those are all the quadrantals. If I asked you to evaluate any of those, you would hopefully know to use the unit circle. And this is all good review. What's this point? 1, 0 up here, 0, 1 over here, negative 1, 0 down here, 0, negative 1. Okay, so go ahead, evaluate all those on your own. Pause the video for a second, and then I'll show you the answers. Okay, so these are always y over x, right? So at 0, y is 0, x is 1, and 0 divided by 1 is 0. At pi over 2, y over x would be 1 over 0. And what happens when the 0 is on the bottom? Undefined. How about over to pi? It would be 0 over negative 1. So we're back to 0. 3 pi over 2? Negative 1 over 0. So back to undefined. And it should be no surprise that 2 pi is the same as 0 because they're the same spots here. It would be 0 over 1, so back to 0. Okay, so tangent essentially alternates between 0 and undefined at the quadrantals. Okay, so how can we use that to make a graph? Well, set up your graph. We're just going to do between 0 and 2 pi. So here's 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, now 0 I can plot easily. So 0, 0 is going to be a point. But how do I plot undefined? This goes back a few units, but right after midterms, we started talking about what happens when the denominator is 0. When you have a fraction, a rational function essentially, and that's what this is. It's really a sine over cosine. That's a rational function, a fractional function. When the denominator equals 0, what happened on the graph? Yeah, I know some of you said out there, It means there's a vertical asymptote. So anytime there's an undefined, a 0 on the bottom, it means we have a vertical asymptote at x equals pi over 2. And there's also going to be one at x equals 3 pi over 2. Okay, so hopefully you kind of seems a little bit familiar. It's been a while since we talked about it. But at pi over 2, we need to have a vertical asymptote. Then at pi, we're back to 0. 3 pi over 2, we have a vertical asymptote again. 2 pi, we're back to 0. And what do you think would happen if I went to 5 pi over 2? That'd be an asymptote in it again. Basically, any pi over 2s are going to be asymptotes, positive or negative. Okay, now let's talk about what else is going to happen. Think about these quadrants. All students try cheating. Between 0 and pi over 2 is tangent positive or negative. Well, everything's positive in quadrant 1. So between here and here, I have to go positive, and I also have to approach the asymptote. Never like plow into asymptotes. So if it's positive, it's got to go up, and it can't cross the asymptote, so it's going to look something like that. How about between pi over 2 and pi? Tangent's negative over here because sine's the only one that's positive. So between pi over 2 and pi, I have to connect to the 0 point, but as I go towards the asymptote, I have to go negative. So it looks like that. How about between pi and 3 pi over 2? That's where tangent's positive. So from here to here, I have to be above the x-axis as I approach the asymptote because all my values are positive. And then finally, between 3 pi over 2 and 2 pi, tangent's negative again. So it's going to look like that. And it will keep going on and on and on in both directions like that. It's got that curvy look to it because you're still going around the unit circle. But that's tangent between 0 and 2 pi. So it looks radically different than sine and cosine. If I asked you for the domain, it'd be kind of tricky to talk about because it's not negative infinity to infinity. Anytime I have these spots, I have an asymptote. So I have places where the domain doesn't exist. So one way to write that, again, this is going to look a little weird to some of you. It's x such that x is not equal to n pi over 2, where n is any integer. Think about what that means. This means it's all x values in the world except any x values that have the form some integer times pi over 2. So 1 pi over 2 is bad. What about 2 pi over 2? That's okay. 3 pi over 2 is bad. 4 pi over 2 would be okay too. That's not an asymptote. So this isn't quite right. It's not just n is any integer. It can't be 1 pi over 2, 3 pi over 2. Next one would be at 5 pi over 2. Here there'd be negative 1 pi over 2, negative 3 pi over 2. What type of integer? Yeah, it's where n is any odd integer. So if I've got an odd integer here, we have an asymptote. Okay, what about the range? Range is how high and low it goes. And look, it goes down forever, and it also goes up forever. So the range of tangent is negative infinity to infinity, unlike the parent sine and cosine curve, which is just negative 1 to 1. What would you say the period of tangent is? Well, is it 2 pi? Does it repeat every 2 pi? It will repeat every 2 pi, but it's actually shorter than that. Here, look, I go up, asymptote, down, up, asymptote, down. So one complete cycle, it starts repeating once I hit pi. So the period of tangent is shorter than sine and cosine. One cycle occurs between 0 and pi, or in other words, it starts repeating after pi. So the period is equal to pi. Okay, so this year, all you're really going to be concerned with is knowing what this graph looks like and being able to make this graph. And you can do it on your calculator too. If I asked you to graph it between 0 and 2 pi, I would just type in tangent of x, clear this out, make your y min 0, your y max 2 pi. If you want it to look exactly like this, we can go by pi over 2's, which I think I already am here. Let's do our y min. We'll just go negative 10 to 10 since it goes to infinity anyways. Being if you did negative 1 to 1, it would look fine. When you hit graph, you're going to see exactly what I have. There's those weird breaks. Those are asymptotes. And there's your tangent graph. So it's probably a good idea to know how to use your calculator for it too, since you always have that available to you. Okay, I'm going to do a couple kind of review questions, but stuff that does show up on the homework tonight, and then I'm done. Okay, determine the value of cosine of theta and tangent of theta given that sine of theta is 5/13 and the terminal ray of theta is in quadrant 2 or lies in quadrant 2. And I want to do this two ways. I want to do it with a picture, and then I'm going to do it with identities. Remember, if it doesn't specify on your homework or whatever which way to do this, you can do it either way you want. I normally gravitate towards picture. I think pictures just make more sense. But if it does specify with identities, which at least one question on the homework does, I know, then make sure you know how to do that way too. So if I was going to do a picture, what quadrant are we in? Well, it says the terminal ray lies in quadrant 2, so that means your angle is in quadrant 2. So draw a triangle in quadrant 2. How would I label it? Well, because sine is 5/13, I know the opposite is 5, and the hypotenuse is 13. Do I know the missing side without doing Pythag? This is one of those Pythagorean triples. A squared plus b squared equals c squared. It would be a squared plus 5 squared equals 13 squared. So a squared plus 25 equals 169. A squared equals 144. Take the square root. We get a equals 12, but remember it's really plus or minus 12. In this case, it's minus 12. Watch those positives and negatives. Easy to lose points on the quiz. Okay, they want you to find cosine and tangent. So now both of these are just as easy because I have my picture. Cosine is adjacent over hypotenuse, which is negative 12 over 13. And tangent of theta would be opposite over adjacent, SOHCAHTOA, so 5 over negative 12. So that's why I like picture, because no matter what they ask you at the end to find, you just got to know your SOHCAHTOA. Okay, so that's with a picture. What if I asked to do that same thing with identities? Okay, well, I have sine and I want to find cosine. So you'd have to think what identity relates sine with cosine. And that is our sine squared theta plus cosine squared theta equals 1. So you plug in 5/13 for sine. So it would be 5/13 squared plus cosine squared theta equals 1. If you square 5/13, don't overthink it, that's 25 over 169 plus cosine squared theta equals 1. Subtract that over. If you can do that in your head, I know some of you can. If you can't, just do 1 minus 25 over 169. And you get 144 over 169. So cosine squared theta equals 144 over 169. Square root it. And I get that cosine of theta equals plus or minus 12 over 13. Because you would just take the square root of 144, square root of 149, you get plus or minus. Now, again, with identities, you have to decide if it's positive or negative. And they tell you that the terminal ray lies in quadrant 2. So if we're doing cosine in quadrant 2, is it positive or negative? Negative. So the answer for cosine is negative 12/13, which is obviously the same that you got with the picture. Okay, so that's how you find cosine with identities. How would I find tangent with identities? Well, again, you have to think of what you have. I need tangent, but I have sine and now I also have cosine, so how is tangent related to sine and cosine? Right, tangent is sine of theta over cosine of theta. So this would be hard to find if you didn't already know cosine, so it's good that we did that first. But sine was 5/13 over cosine was negative 12/13. Complex fraction, multiply top and bottom by 13. So negative 5/12. And the negative kind of comes for free, but tangent in quadrant 2 should be negative. You can check it that way. All right, so that is the end of new stuff for the trig unit. You've got tonight's homework. Tomorrow's a review day, so I'll do a little bit of review tomorrow with you. But give the homework a shot. Congratulations to making it to the end of trig.